did a code before, right? Did we? Where we have a structure
Yep.
and we get a string and we do some operations here. No, I'm sorry, we're going to get the string first. We do some operations, we set straight away, we set some values, allocate some memory, string copy some things down to this point. Is that right? Anybody have any questions? Did we go over all that, or do we need to do some more on that?
I believe so.
Well, let's, I guess,
If it's in question.
let me put a breakpoint there. And we talked about std without the using command. Okay. Let's see, Jesse, you just came in?
Yeah.
Okay. All right. Let me start here. See if this program will compile. How about that? It does. What does this notation say and what does it mean? Splat, left parent, nm temp plus 2, arrow, xptr equals new char 2. What is nm temp, first of all? It's kind of a issue that we need to resolve. nm temp is a pointer to a structure, right? That's its data type. And nm is a character, is a structure that has a character pointer in it and an integer number. How long is a structure nm? How big is it? First test question. Can you compute it? Tyler? How many bytes in a structure when we allocate one for nm?
For NM, it would be the, when you allocate the structure,
When we allocate the structure, how big is it?
it's the size of all the variables added up.
And therefore, how big is xptr?
Let's see, char is 1 byte, right?
So it's one address.
Or, oh, it's one address, because it points to
Right.
an address and stores.
This means address, right? The splat means address. So xptr is 4 bytes
4 bytes.
and num is 4 bytes.
4 bytes, 8.
So when we allocate it, we have 8 bytes total. This declaration right here, how much space does it occupy?
Does not change.
None. It's a declaration of a data type, right? So the declaration itself doesn't occupy any space. We have a couple of prototypes here: get string and process string. We have function main. We've set up the debugging, tracing, and nm temp is a pointer to a structure, and nm struct is also a pointer to a structure, and nm pointer is a pointer to a structure, and nm temp gets new nm splat 4. So what is the L value here? Well, it's this address, isn't it? And what is the R value here? Jeff?
The R value would pieces in the array, so four bytes.
So how much memory is actually allocated and assigned then to NMTemp?
4 bytes, plus then also be 5.
4 bytes. No. Dakota, you want to give it a shot? Justin? Anybody? Well, let's take a look at it. We're allocating 4 elements, an array of 4. Each element in the array is a pointer. An address. Therefore, it's 4 bytes for one of them. And the fact that it points to a structure, well, that's nice. But the issue here is 4 bytes each element, and there are 4 of them, so we get 16 bytes total. Right? Everybody see that? So we're assigning to temp this array, the start address of the array of pointers. And then we allocate just a single structure, place its address in NM pointer. We allocate an array of characters, no splats there, right? So that's exactly 5 bytes. And that is placed into the XPTR field or member of the structure pointed at by NMPTR. Right? That's how we read that. The left-hand side here. The left-hand side must resolve to a location. There has to be a location value there. And that location value is location XPTR. Where is XPTR? I don't know, but it is part of, it's a member of, it is a member of the the structure that's pointed at by NMPTR. So right here we allocated a new structure, pointed to it by the NMPTR, and XPTR gets, that's the member of it, it's pointed at, this thing is pointed at by this one. Do I need to draw a picture of this piece? We got it clear? Dynamically allocated pointer to a structure. Therefore, XPTR is something that doesn't have a value initially. Notice it's a pointer to a character. And so we assign XPTR some address space, and we read this by saying XPTR member of the structure, that's the arrow, of the structure pointed at by, again, NMPTR, going right to left. Right, remember that from last time? So then we have to string copy the string Mary into what XPTR points at. And then we set num, that's the num member of, which is an integer. We can just do a straight assignment since this is an integer. The num member of structure pointed at by NMPTR. And I'm using some terms that we want to become familiar with. Member of is an important term. Members of objects and members of structures, one and the same thing. And when we have dynamic structures and dynamic objects, we have to have a pointer to them. So here is a pointer to a structure, and when we do the reference to a member, then when we do a reference from a member of a dynamic structure, dynamically allocated structure, we use the arrow operator. Here's a test question. can I say that? Why not, Justin?
Because it's a pointer to an address.
Pardon me?
Because it's a pointer.
Which is, what one is a pointer?
The L value.
But what part of that, this
The
expression is a pointer?
NMPTR.
Pardon me?
The left-hand side.
Yeah. Is num a pointer?
That's a it's part of the structure.
Okay, it's a member of
Member.
a structure, right?
Mm-hmm.
So that part's okay.
Mm-hmm.
The dot says what? Compare and contrast. Here's another kind of a question, same issue. Compare and contrast the dot notation and the arrow notation. This one will not work this way. This one does work this way. What would I have to do to fix this one up?
The arrow key.
If I put an arrow there, okay. Can I do it with a dot? Tyler?
Put the
Yeah,
structure.
you can. I think it's dependent on your structure up above, right? Because your structure is pointing to pointers, right? Not, pointing
So
to-
we know that this is a pointer, right? And so if I use the dot notation, what does it assume about the left-hand side over here?
It's part of that structure.
It's actually a structure, not a pointer to a structure. Did we declare any of those? No, we didn't declare anything like that. So if we did, let's call it NM, and we'll call this NM structure. That's the name of the variable. So in that case, I could say NM struct dot num equals 1, and everything's cool, right? Because this structure is actually allocated. This one is a pointer to something that is a structure, and we hope it has been allocated. Whenever I do the NM, let me put that back just a second. Didn't want to do it right there, I wanted to do it down here. Notice that we get some assistance in typing, in case we don't remember what the member of the structure was. We can, when we do the dot notation, what comes next, the IntelliSense piece comes from Visual Studio and gives me a list of the values that are members of that structure. But notice that it didn't do that over here. Why not?
It's not a member.
It's not legal.
Because what's to its left is not a structure. It's a pointer to a structure. Is that clear? Now, if we wanted to use dot notation, then I would have to do that business, and then, whoops. And you'll notice that in this context, we get the help, the IntelliSense, because Visual Studio recognizes that the stuff to the left of the cursor there is a dereferenced pointer, right? So we know where the actual structure is and that it is actually a structure, and we can use the dot notation. So that's perfectly legitimate. This and this one and this one say exactly the same thing. Is that clear? Which one would you prefer to type? The arrow or the dot notation? The arrow notation is what most people prefer to do. Okay. Any questions there? I think we went over this last time. I think we did. Maybe not in as much detail as we needed to. All right. So the next thing is this line, splat nm temp gets nm pointer.